Here we go with lesson 4-4, solving equations by multiplying and dividing. So last class we were focusing on adding and subtracting. Now we are multiplying and dividing. Again, working with inverse operations. These are operations that undo each other. The inverse operation of multiplication is division, and the inverse operation of division is multiplication. Okay, so you've seen examples like these in the past. We can take a look at some basic examples. 5 times some number equals 10. Okay, so I know you know the answer in your head, at least I hope you do, that the solution is in fact 2. But we want to balance to prove that x is equal to 2. So here we have to recognize that we have multiplication. If you need to put a multiplication dot in there to see the math, go ahead and do it. To undo multiplication, we need to divide. Now, we must use the fraction bar. It will be a lot easier that way. We always want to divide by the value that's being multiplied by the variable. So in this case, 5. Why are we doing that? Well, 1, division is the inverse operation of multiplication, but 2, it allows the x to become isolated because again, that is our goal. 5 divided by 5 is 1. That leaves us with just one x. 10 divided by 5 is 2. By the multiplicative identity, I know that this will equal x. 1 times x is x. And there's my solution. X is equal to 2. I do expect you to show the balancing step on each side of the equation. I expect you to write your variable in the solution as well. We can check this by substituting 2 back into that original equation. 5 times 2, does it equal 10? Yes, it does. Okay, let's look at something a little bit more interesting, a little bit more at the 7th grade level. So let's say we have something like this. 2/3 x equals 10. We can stick with 10, why not? Same idea. You might look at 2/3 and go, whoa, what's happening here? Just remember, 2/3 is a number just like 5. And it's also being multiplied by x just as 5 was being multiplied by x. So how do we undo multiplication? We divide. Now there is another way to solve and balance this equation, but let's stick with this for now. So there's my fraction bar for division. Well, what am I going to divide by? The number right next to x. Before it was 5. Now it's 2/3. The steps stay the same. Keep that in mind. They stay the same. This looks a little bit funkier, I will admit, but we need to do it in order to solve this equation. Okay? 2/3 divided by 2/3 is equal to 1. That's the lovely thing. That drops out. We get just x. And then I have to figure out what 10 divided by 2/3 happens to be. Be careful how you write this horizontally. The 10 has to be written first. 10 divided by 2/3. We've already practiced dividing whole numbers by fractions, so let's go ahead and use our skills. 10 over 1 times the reciprocal. We can go ahead and cancel out. I get 5 times 3, that's 15. So x is equal to 15. We can check this by substituting x equaling 15 back into the original equation. So that original equation was 2/3 times x, in this case it's 15, and does it equal 10? Okay, well if we put 15 over 1, we can cancel out. We would in fact get 10, so it checks. Now I mentioned before this is not the only way to solve this problem. Remember, division is the same thing as multiplying by the multiplicative inverse. So let's rewrite the equation, and let me just say division is the same thing as multiplying by the reciprocal or multiplicative inverse. Because some of you might have noticed this anyway. Basically, we want to get x alone. So we could divide each side by 2/3. But we could also multiply each side by 3/2. Why are we allowed to do that? Well, dividing by 2/3 is the same thing as multiplying by 3/2, the multiplicative inverse of 2/3. And what happens is when we do this multiplication here, everything cancels out. We still get 1 and we have x, so 1x equals, and then 10 times 3/2. We can do this. You cross cancel, you get 5 times 3. You still get 15. So both methods work. It doesn't matter to me which one you feel more comfortable using, as long as you balance your equation correctly, get 1 next to x, and get your solution. Okay, x is equaling to 15. So that was a multiplication equation. What about division? So let's say we have a variable y being divided by -4, and it's equal to -9. You have to be very careful with division. A lot of times I see people wanting to divide when they see division, but you can't. Remember, you need to multiply. And I'm going to show you why we need to multiply. Sometimes people are not sure what to do because they don't know how the math works. So here we are dividing by -4. To undo the division, we need to multiply by -4. So let me balance by multiplying by -4 on each side of the equation. So what is actually going on? Well, -4 is an integer, -4 over 1, I can rewrite it that way, times y over -4 equals -9 times -4. I'm just rewriting it a little bit so we can see the math. We can see what happens. Here you'll notice that -4 divided by -4, that cancels out to 1. And that's what we want. We want it to cancel out to 1 so that we have y alone, 1y. Okay. And we can do the math over here. We get a positive 36. 1 times y is y. Okay, and there's my solution. I can check it by going back to that original equation and putting 36 in and asking myself, what is 36 divided by -4? Well, it's -9. And that gives me a true statement. Let's do a couple more examples. Let's say we have something like this. 5x minus 8x equals -24. This looks a little confusing. We have two x's. What do we do? Well, let's go back to what I said last lesson. Simplify. Something looks a little bit funky. Ask yourself, are you able to combine any like terms before balancing? And in this case we can. Now we could do it because it's all on the same side of the equation. Okay, we have to have like terms on the same side in order to combine them. So let's help ourselves out. Change this to plus negative. 5x plus -8x. That will give us 8 minus 5, which is 3. It will be negative. I must keep the x because I am adding. So I get -3x equals -24. Already my equation looks much simpler. I am multiplying, so in order to undo the multiplication, I need to divide. -3 divided by -3 is 1. That gives me x. Negative divided by negative is positive, and I do in fact get 8. I can check this one as well. Going back to that original equation, 5 times 8, so again that's my x, minus 8 times 8, there's my x again. Does that equal -24? Well, 5 times 8 gives us 40, minus 8 times 8, which is 64. Does that equal -24? Yes, it does. I can change it to plus negative to help me see it that way. 64 minus 40 gives me the 24. I know it will be negative because of that -64. So everything checks out. But make sure you are using the original equation. Okay, go back to the very beginning and substitute your value in for x there. I would like you to go ahead and to try this one on your own first. Y over -2 equals -17 minus 9. Please hit pause and unpause when you're ready for the solution. Okay, so what can you do? Well, Let's see, I have negative 17 minus 9 on one side of the equation. Let's go ahead and simplify that first. I have a negative plus a negative. I am going to go ahead and add those values together. 17 plus 9 gives me 26. I know it will be negative 26 because both of these values are negative. And voila, I have a much simpler equation to work with. So now I'm looking at y. Y divided by negative 2. To undo division, I need to multiply. You don't have to write times negative 2 over 1 on the left-hand side, but I know it helps me to see the math. So feel free to do that, or if you'd like to just write times negative 2, that's fine as well. Okay, this will give us a positive 52. If we checked this, it would check out. Another example that's pretty cool, let's look at this. Negative x equals negative 4. It's really deceiving because people immediately want to tell me that the answer is negative 4 when it's not. Always write a 1 in front of lone variables. That should sound familiar. So x looks like it's alone. Let's go ahead and throw that 1 in front. That is its coefficient. Okay, it's much easier that way because then you can actually see the multiplication. I have negative 1 times x equaling negative 4. Now that I know that I have negative 1 being multiplied by x, I can undo that by division. X equals positive 4. Just so you know, you could also solve this by multiplying each side by negative 1. Because the result is the same. A negative times a negative is a positive. This would still give us a positive x. Okay, and a 4. And it does check out. Sometimes people don't believe me, but it does. I want to know if negative x is equal to negative 4. Well, if I put a 4 in there, do I get negative 4? In fact, I do. So it works. Let's take a look at a word problem together. Please get out page 26. Let's take a look at number 31. Each student needs 12 minutes to give a report. A class period is 48 minutes long. Write and solve an equation to determine the number of students who could give a report in one class period. Okay, as a teacher, this is important. You want to make sure that you have enough time to get through all of the reports. So let's define our variable. What don't we know? What are we trying to find? Well, we're trying to find the number of students who can give a report in one period. And let's go ahead and set that equal to S. Okay. So the number of students who can give a report in one period. So I know that each student needs 12 minutes. So let's just think through this. So 12 minutes equals one student. So what if I had 2 students go? How long would that take? Well, that would be 12 plus 12, which is 24. What if I have 3 students who want to go? Well, I'd add on another 12 minutes to that, and I get 36 minutes. So the question is, what's happening here? What's that pattern? Well, I'm multiplying. Okay, 3 times 12 gives me 36. 2 times 12 gives me 24. 1 times 12 gives me 12. Okay. So we're working with multiplication in this case. So if I had S number of students, in order to figure out how much time that would take, I'd need to multiply that by 12. So S number of students times 12 would give me the total amount of time we are working with. Well, what is that total amount of time? Oh, they told us that a class period is 48 minutes long. So already I'm starting to see an equation take place. Remember, we want to have a total by itself. We have a total of 48 minutes, and I know that I have S students and it takes each one 12 minutes. So 12 times however many students go needs to equal that 48, and there's my equation. We can balance this to solve it. We are going to divide and go ahead and check it. What are you going to get? What is 48 divided by 12? Yep, 4 students. Okay, thank you. I'll see you in class.